Hi, good afternoon and welcome to our session. The good news is this is the last session. The bad news is 3 hours, okay? So, I'm Silvano Ravotto and speaking with me, Mark Chiarini. Mark and I are part of the performance engineering team at MarkLogic. And our team is responsible for characterizing the performance of new MarkLogic features, as well as helping customers in capacity planning and troubleshooting performance issues. I've been with MarkLogic for a long time, almost 10 years. And before joining the engineering team, I was actually part of the professional services. And I might have worked with some of you in the past. Mark.
Hi, thanks for coming today. My name is Mark Chiarini, and I've been with MarkLogic as a performance engineer for about 2.5 years. Prior to MarkLogic, I completed a PhD in computer science at Tufts University, and I did a computing innovation fellowship at Harvard. Recently, I've been focused on benchmarking MarkLogic server on various storage platforms, as well as studying and exploring Windows tools for performance analysis, which I'll talk a little bit about today. Feel free to find me in between sessions if you have performance questions. I hope I'll be able to help you.
Thank you, Mark. Okay, so just the agenda, very quickly. Today we will talk about monitoring and tuning MarkLogic. And we briefly introduce some methodologies that can be used to analyze systems. And then we'll present a few tools to observe performances at various levels. And finally, we'll discuss some tuning guidelines. But before we start talking about technology, I'd like to take a quick step back in time. These two fellows are not Mark and I, by the way. They are two famous Italian artists, and you might recognize one of them in Dante Alighieri. Dante, as you might know, wrote the Divina Commedia, where he imagined he traveled in the afterlife. So you may agree with me that sometimes when you are stuck in a big performance problem, you feel you are in Dante's Inferno. And to illustrate my point, I'm going to use a painting from this other guy, which is Botticelli. He was able to summarize 34,000 words, actually more than that, in one picture. That's pretty awesome. You see all the circles. Do they look familiar to you? Of course they do. Yeah, systems are complex. There are different layers, and each one has its own performance challenge. A typical system consists of several nodes running applications that depends on third-party software, like MarkLogic, on top of operating systems that could be virtualized. And finally, you have the hardware with its own resources, like the CPU, disk, memory, network, and so on. As we will see, it's very important to get familiar with each layer and get the right tools to analyze and explore them. So if you feel overwhelmed, actually there are plenty of resources that are available to help you. And like Dante was helped by Virgilio in his journey. In performance engineering, I definitely recommend you to become familiar with the work of Brandon Gregg, a performance engineer at Netflix. His website and book provide a lot of insight to help understanding performance of complex systems. So the first step is actually to use some methodologies. And basically, those are a set of procedures that you use consistently to analyze the system. They provide you a starting point, and you might need more than one to accomplish your goal. Some examples of good methodologies are listed here. The first two are actually kind of similar, and we'll see an example shortly. Basically, you keep asking yourself why you see a behavior until you get to a satisfying explanation of the issue you're experiencing. The use method is a particularly good one to start your investigation. And basically, for each resource, you have to ask yourself 3 questions. What is the utilization? Is there any saturation? Or are there any errors? For instance, if the resource is the CPU, you can check SAR, TOP, or something like that to check the system utilization, the user utilization, and you can also look at the load. If the average load is greater than the number of processor, then you might have saturation. And of course, you have to check for errors. Is the CPU offline? Something like that. So having a set of processes in place is well and good, but you also need a set of tools to observe the performance at various levels. However, don't just rely on one tool, but confirm your findings with other tools. There are tools that can be used at the application level, like the MarkLogic monitoring history. Tools that are part of your infrastructure. For instance, in the cloud, you might find Amazon CloudWatch. And within enterprise, there are tools like Nagios. How many people are using Nagios here? OK, cool. How many people are using New Relic? OK. And obviously, there are other ones. I use in MarkLogic the Performance Copilot. Anybody using it? Excellent. No one. Huh? And finally, obviously, if you have need more fine-grained information, you need the Linux or Windows tool, as we will see and discuss in detail. As you might know, the MarkLogic server provides a monitoring dashboard that you can use to quickly see a summary of the cluster health. It is available on port 8002, and it requires the metering to be enabled at the group level. What you get in the monitoring history is the server view of the resource. It does cover the main resources, like disk, CPU, memory, and also database logs, database deadlocks, and things like that. So it is very useful to get an idea of your baseline performance. However, as I said before, don't rely just on that. In particular, if you have a serious issue that can cause the MarkLogic process to hang, it's unlikely that you'll find the problem there, because you're going to have incomplete information. So you need to find your root cause somewhere else. And from an infrastructure point of view, if you're in the cloud, you might take advantage of the tools that the various vendors provide. For instance, the Amazon CloudWatch. Amazon CloudWatch allows you to track metrics and logs about resources like EC2, EBS, and ELB. EBS are the storage, ELB the load balancer. Those are typically resources that you would typically use if you have a MarkLogic cloud deployment. And they also provide a set of APIs that allow you to push your own metrics. So for instance, you can leverage the MarkLogic REST API to collect some metrics and then push them into Amazon CloudWatch. And then you have one place to look for that information, at least at a very high level. As I mentioned before, there are several tools that you can use within an enterprise. And the one that I use, and nobody else uses, it's a Performance Copilot. And I guess I like it because there is actually a lot of current development on the tools, and you might get like new features almost every day. Well, not every day, but often. And what I like about it is that you can choose several ways to gather the statistics, either from a command line and also from a graphical perspective. And it is available on multiple platforms, including Linux, Windows, and Mac OS. It's very easy to extend, just using Perl or Python script. I wrote a very, very basic plugin for MarkLogic, which is available on GitHub if you're interested. Sample. Yeah, coming up. So those are sample PCP commands. For instance, if you want to just get an highlight of the various resources, if you're familiar with VMstat, it's basically the same. It's PMstat, and again, high-level metrics. PMinfo will dump all the metrics that you can collect from PCP. And if you're interested to do like a more in-depth analysis, you can dump the metrics for a particular time frame, using PM dump text. And for instance, you can use other tools like Excel or Studio to analyze the performance, especially if you have many nodes. It's very useful if you have a cluster of 100 nodes. There are some graphical tools. This is just one example. This is a Vector, which is a tool from Netflix. And it provides a very simple real-time dashboard of the main metrics. You can select the refresh intervals of very aggressive, a few seconds, even 2 seconds, in case you're trying to chase a very short spike in resource utilization. So Linux has many tools available. Since we're going to talk about each one of them in details, that's why it's 3 hours. So now this is a joke aside. This is a great slide from Brendan Gregg again that illustrates the Linux architecture. There are many commands that you can use when you are really looking at a particular area of the Linux architecture. Honestly, there are commands that I never used, but I'm pretty sure one day I will. One tool that I do use quite a lot is perf. Perf basically allows you to detect the CPU utilization and what are the functions, either on the user level or system level, that are using the CPU. With perf top, you can simply get a quick highlight of what are the hottest functions in CPU. And if you need to do like a more detailed analysis, you can record the activity for a minute or so, 2 minutes, and then you can have a report that prints out the information. The report looks something like this, which it shows how much time is spent by each function on the CPU, both from a shallow time and a deep time. It also gives you a stack trace, so you have a context, and it is helpful to understand the logic. So perf reports are actually good, but even better are a graphical representation of them in terms of a flame graph. The flame graph in the vertical axis represent the call stack, and the horizontal axis represent how much time was spent along each call stack. This particular flame graph, for instance, shows an ingestion process, very simple ingestion process in MarkLogic. You'll notice on your left the time that is spent in flushing in-memory stands into disk, the time that we spent doing merges, and finally the time that we spend in parsing and indexing a document. I'm going to conclude my part of the talk with a case study. And what I'm hoping to show that is the importance of capturing the information from the various tools and the various levels. We definitely don't expect our customer to analyze p-stacks or perf reports, but those are important information to capture and make sure that you have available if you have to contact our support. So this particular case, customer is using MarkLogic in a batch environment. And in this particular case, we are focusing on the ingestion of content of MarkLogic. They were experiencing a sharp performance degradation with their growing database, and they reached a point where their SLA was in jeopardy. So they engaged our support team, and what I'm going to show you is just the successful path to the resolution of the main issue. We actually uncovered other issues, but for the sake of clarity, I'm going to stick with their main issue. So I spoke about the use methodology and check utilization, saturation, errors for each resource. A good place to start is the CPU. We immediately saw that the CPU was mostly waiting on I/O operation, and we needed to figure out why. So we took a closer look at the I/O matrix, and you can see the utilization is high, and the await is in double digit, which is definitely a sign of I/O saturation. However, the most important clue was that the reads were dominating the writes, and this was an ingestion process. So we were trying to figure out what was going on. So the next step was asking the customer to take p-stacks. P-stacks are just basically snapshot of the running threads. And we found that there were many threads waiting on random reads, this p read 64 that you see in yellow. We correlated these threads to other threads, and we found out that many originated from CTS URI calls. So it was time to take another closer look at the code. We determined that the random reads were caused by an element value query on a document ID. This seems a very innocent query. Why was it causing such a performance hit? Well, it turns out that element value query for a unique ID could be fairly expensive. In MarkLogic, when you're looking for a term, you are querying a memory structure that is called a list index. That tells, and this structure tells the system where the term list for a particular term might be stored on disk. The term list is the list of documents where the term is. The memory structure doesn't have enough information for all the terms, so you actually need to look on a block on disk and break this block on from disk to memory, and then look within the block. And typically, block could be like a 4K or larger block of disk. And given this is a unique ID, it's probably not cached. So, and this is done in parallel for all the stands in each forest. So in the worst case scenario, the total reads per second are equal to the number of documents you're ingesting per second times the number of stands you have on a particular node. So if my math is right, if you have 20 stands and you have 500 documents per second, and you want to achieve 500 documents per second, this means 10,000 read per second on each node, which is quite high. So now we found the culprit. The goal was reduce I/O. So in order to avoid that, you can use a range index on this unique ID. The range index is fully mapped into memory, and therefore there is no I/O anymore. Once the index is in place, you would have to change the code. And basically in the CTS URI's call, we would have to change the element value query to element range query. And once we did that, that particular performance issue went away. So just to recap, remember the first thing is to understand what the problem you're facing. Analyze each layer carefully. As you drill down, collect the new metrics and validate your hypothesis. Once you found the most likely root cause, look for solution. Try to make one change at a time, because otherwise, things can get tricky. And with that, I'm going to ask Mark to come up, and he's going to talk about Windows, tools, and tuning guidelines. Thank you. Yeah.
Because the IDs are not in the memory, right?
Correct.
So if it's in the memory, then it's going to fetch faster. So can I give my query to MarkLogic and utilize or provide a plan so that I can optimize I can change my query automatically instead of coming to a support person?
Well, we have tools like a XDMP plan, which is a function that basically lists the plan.
Only the admin can run that plan?
No, you can. Anybody that can run a query can run an XDMP plan. Sorry, we'll just keep the question at the end, maybe.
Yeah.
Thanks.
There's another session coming up that can help you with that too. So again, my name is Mark Curini, and I'll be talking a little bit about Windows tools for doing some performance analysis. Don't want to leave any Windows platform users of MarkLogic server out. And by a show of hands, who would like me to continue the presentation in an Italian accent? Okay. È possibile, I can do it. Okay. So, as most of you may have guessed, a lot of the performance analysis tools for Windows are primarily GUI based, right? But we can export a lot of important information from those GUI tools. Each of these tools that I'm going to talk about are progressively more powerful and detailed. The first one is Process Explorer. All of these tools come from Windows, from Microsoft. Process Explorer is essentially a task manager drop-in. So you can use it in the same way that you use current Task Manager, and some of you may be familiar with it. Process Monitor is a tool that records system calls and thread activity in much the same way as perf does on Linux. And finally, WPA, or the Windows Performance Analyzer, is a fine-grained tool to provide detail on the CPU, memory, disk, network activity, all the resources that you normally look at. So let's delve into Process Explorer. This is, like I said, a comprehensive replacement for Windows Task Manager, and it does a whole lot more than Windows Task Manager. It gives you a sense of performance and performance problems in the moment. So it's not really very useful for any kind of post-mortem analysis. And it's available here at internally at Microsoft TechNet. So this is the Process Explorer main window. And if you wait a second, you see that green bar come up. That's MarkLogic starting its process. And you can see that there's different columns available: memory, resident set size, how many handles they have open. There's all the different possible information that you might want for an individual process, sort of in a snapshot right there. And then at the bottom, there's sort of aggregate statistics. So we can also do something like pulling up the properties window for MarkLogic itself. And once we do that, we can get a sense of how it's using CPU, memory, and I/O in real time. If you mouse over the individual graphs, they show us the resource utilization at the given point in time. And anytime we see excessive resource consumption, it appears as a long-term or a short-term spike here. It could be cause for concern, right? Now, we don't necessarily know it's cause for concern until we do more investigation, like using some of the other tools that in the methodology that Silvano mentioned. Other tabs in the property window can also give us a sense of performance from a textual perspective, and all of this stuff can be exported from ProcEx and some of the other tools that we're using as well. So here we see performance in terms of CPU, I/O, virtual memory, physical memory, and it's just aggregate summary numbers. Here we see disk and network statistics on about the ML process that was captured since ProcEx was started. Right, so it's not running in the background before you start the program. It's once you start the program, you run it, but you can have it running on a production server, and it doesn't take many resources at all. You just have it running sort of like your regular task manager, and then you can go in there from time to time. There's also a detailed resource view. It's called System Information, and that lets us see CPU, memory, and I/O for the entire system. So not just MarkLogic. You should be only running MarkLogic on your system, but just in case you're not, or if there's other third-party tools that you may be running on your production servers, you may be able to see if there's maybe a memory leak or something of that nature coming out of that, and not necessarily the MarkLogic process. And as I showed you in this animation, actually, you can click on view multiple CPUs, so you can see what each CPU is doing, and that can be helpful in certain ways if you don't think that some portion of your CPUs is getting enough work, for example. And then we have the I/O panel. Essentially, these are all just breakdowns and details in Process Explorer for a particular process. In this case, MarkLogic, and this is the memory I/O. And again, as you mouse over, you can get slightly more detailed statistics about something. So that's ProcExp. And then a second more powerful tool that helps us correlate groups of MarkLogic operations with resource utilization is ProcMon. It records and it filters Windows system call statistics. So it's basically saying, okay, I've got an operation, I accessed a file, I'm going to record that. I accessed the registry, I'm going to record that. So it gives you a log of every single operation that's happening during a capture, what we call a capture. It can also do thread profiling. So in much the same way as perf is doing, it's saying, okay, or a pstack, it's giving you all the calls that are happening in each individual thread. And it can tell you how much time was spent on CPU or waiting for disk I/O or any of the other statistics that we normally like. It's particularly useful for finding abnormal conditions or errors that can lead to performance problems. It's not necessarily the performance problem itself or a symptom, but it could be a cause of that. And again, available at TechNet. So this is the main window. I apologize if the type is a little bit small. And what we see here is a list of events that have occurred. So these are essentially operations that we've captured during the course of a run, as long as we want to run the recording, so to speak. So the columns are configurable, and you have something called an event class. So you might have registry, you might have file system events or process creation events, and the time and duration of the event as well as the result. You have quick access to all the functionality through the toolbar, which you see here. And for example, if you want to start or stop the capture, you press that button. If you want to start or stop auto-scrolling in the window, if you've got a lot of events going on, it's going to scroll like crazy and you're not going to be able to see anything until you stop the scrolling. You can clear the log temporarily just to see, just to get your bearings. Sometimes it's a little overwhelming. If you press any of these buttons on the right, you'll see you'll filter out certain kinds of events. So right now we have all the events showing. If you press the button that you see there, you'll show file system events that occurred, or you can show process and thread events that occurred. Then we have the context menu, which lets us jump to bookmarked events, include or exclude or highlight events, and filter in time. So as you go down that, you can exclude events before or after a particular event, or you can filter out all the events that have success in the particular result column. And then what we can do is we can kind of correlate these events with the actual graph of what was happening. So here we have CPU, and we have I/O, and we have registry events, and things like that. And so in the process timeline, we can click on any graph point to jump to the first event in the event window that correlates to that behavior. So if you see some spike in CPU, you can jump to the first time that was starting to occur, and what event is sort of the beginning of that process. And then we have more advanced features, including being able to count the occurrences of values in any event column, window column. So we can say, in column result, let's count the occurrences of some particular value. So in here we see 47,000 some odd success results. Maybe those are not very interesting as events, so we may want to filter them out at some point. It's very useful for seeing if there are more bad values for something than expected. So like, let's say you see, here we only see path not found 39 times or so, but maybe if you saw 1,000 times, you'd be like, what is going on exactly? Why is it not finding this path in particular? We can look at file system activity, which particular paths were accessed, how frequently, right? And this is another area that we might be able to find something that's going on. Why does it keep trying to access this particular area of the file system that we don't expect it to? The general workflow is that you capture a short trace just to kind of get your bearings, determine the event classes of interest. Are you interested in registry events? Are you interested in file system events? Maybe you're not. Maybe you don't really care about the registry. Everything's working fine. Then you can capture a longer trace, capturing the the areas where you may be having problems, right? You're spiking or wherever. You filter out the disinteresting events, such as I mentioned before, successful system calls, and then you can search for unusually high or low event counts for particular things, or errors. That's another good one. And then it's a very good tool to be able to also send stack traces of unexpected activity to the ML support group. So the workflow I'm showing you here is I'm right-clicking on the success cell value particular thing, and I'm saying filter it out. So then we get a reduced event count in the lower left corner. It may be difficult to read, but there's an event count of how many events are being shown in the window, right? And the goal is to sort of trim these down further and further and further until you get to events of potential interest. So, you know, in this particular case, we've trimmed down to like 45 events that we can look at and say, okay, are any of these really, really weird? So that was Procmon. Now, Windows Performance Analyzer is a comprehensive, detailed tracing of all activities. If you didn't get enough with Procmon, there's more. And what you can do is, you know, the tool provides on-screen highlighting and correlation of events that are happening at the same time. So maybe your disk is, you know, maxed out and your CPU is really high and you've got a lot of network I/O. What's going on? You know, and that's available as part of the Windows Assessment and Deployment Kit, also at Microsoft. And as a third-party resource, be sure to check out Bruce Dawson's UI for ETW, which is Event Tracing for Windows, available at his blog. He's done tremendous work. He primarily works for developing Chrome, and he tries to debug Chrome on Windows, and so he's been using UI for ETW that he developed himself. This captures the traces, and this also starts up WPA with all the best settings. So this is the main window, and you can see that the main parts of this are that on the left-hand side you have all different kinds of graphs of all different kinds of resources and presented in all different kinds of ways. You can drag any of those graphs into on the left into the main window, and then they'll show up, and you can show it in tabular format and you can show them in graphic format. And similar to a Linux perf profile, for example, the CPU usage table in the middle there can be sorted according to the amount of time spent in a MarkLogic function, for example, or you can sort by any other column. And you can easily correlate activities on different resources. So for example, in this slide, the vertical bar is shown across CPU on the top and memory on the bottom. So you might be able to correlate and say, oh, I'm using a whole lot of memory, right? Does this have anything to do with, am I actually processing anything useful, or am I just using that memory and spinning on something? UI for ETW can also produce flame graphs based on WPA profiling data. So that's a plus, and that's a sort of an equivalent across Linux and Windows tools in this case. The flame graphs are really nice. So again, in summary, for the Windows tools, similar to Linux, there's a set of Windows tools you can use to observe and analyze MarkLogic performance almost at any level. ProcX is good for in-the-moment observations, right? When you want to see what's going on right now. Procmon's good for finding unexpected behaviors in Windows system calls in particular. And then WPA is really good for correlating resource usage across all the MarkLogic functions. It's really a very comprehensive tool, and we're starting to use it more and more. So now, the moment you've all been waiting for. Yeah. Yeah, this only runs right now on one node, one server, right? So if you want to do greater correlation, there are some tools out there, but it becomes more difficult. There's no like one Windows tool that'll do it for you. Good question, by the way. So to conclude our session, we'll cover some of the most common targets for tuning activities. Except for a couple operating system tunables, these tuning targets are available for Linux and Windows. And similar to monitoring, each layer of the system architecture has its own targets and tunables, right? So if your target is application, you're going to be looking at tuning queries. At the server level, you're looking at tuning indexing, cache, MVCC settings. At the operating system level, huge pages, virtual memory settings, and at the storage layer, RAID level and what your IS scheduler is. So for the application target, query meters, query plan, you can use XDMP query meters and plan, like the gentleman was asking about before, to verify if the queries are performing correctly. Are they using the right indexes? Are they loading too many documents in memory? We've got the Profiler API that you can use to verify the efficiency of the code. For more info, Aaron Miller, my colleague, will be presenting, is it tomorrow? On tuning for applications. So at the server level, there's many ways to optimize the server, with the most common one being to change cache settings. Cache is huge with MarkLogic. If you have a large amount of memory, you can increase the caches to limit I/O. But you should check XDMP cache status function to see cache utilization to make sure that you're not overcommitting. And more partitions can also improve concurrency and reduce contention. Indexes are also important, presenting you with a trade-off between space and performance. The more indexes, the more queries you can resolve directly in the indexes without having to filter the results. And then finally, MVCC is a setting at the application server level that may improve performance of queries if you set it to non-blocking. Right? This allows multiple things to read at the same time without locks, for search, especially for search engine-like use cases. At the OS level, turn off transparent huge pages. You don't have to say more than that. Okay? In virtual memory, you want to reduce swappiness, which causes the kernel to avoid unnecessary swapping of runtime memory to disk. There's a little bit of a balancing act there too. And in machines with many physical CPUs, we've seen performance improve when reclaim mode is disabled. Reclaim, in this case, we prefer to have a caching effect rather than locality of code and data. And finally, at the storage layer, in many cases it's vendor specific. But depending on whether you're looking for performance or capacity, you may want to choose RAID 10 versus RAID 5. There are some other more esoteric configurations that you can make, but you'll have to do your mileage may vary on that. RAID 5 for capacity. For the I/O scheduler, the thing that determines how it's going to group writes and reads from the disk, we discourage using the completely fair queue in favor of deadline or even no-op. If you have smart RAID storage arrays, probably use no-op. It's probably your best bet in case you have smart storage arrays. And then finally, one thing that we encourage you to do is to leverage the tiered storage feature that we have. In complex deployments where you have different access patterns depending on the age of the data, the content, or other properties, the tiered storage may provide benefits where you can mix highly performant hardware for frequently requested stuff, tier 1, with hardware configured for capacity for rarely accessed content. So what's the takeaway? Really, the takeaway is not what do the tools do and how to use them exactly, but the takeaway is really about following good best practice and good methodologies, as Silvano mentioned. When you're really troubleshooting performance issues, you want to understand as much as you can the issue that's being reported, right? If you're getting it from a client, so to speak, if you're doing IT or whatever, explore it. Don't just let them tell you the information one time. See what else they're seeing. Decide on what data and metrics that you're going to collect after you've explored that problem, and then decide how to analyze it. That's the case of where the tools come into play. And then once you're choosing your tools, don't just trust a single tool, right? Because it may be not necessarily lying to you, but omitting information that may be very useful to figuring things out. And you should gather metrics, over time as you're troubleshooting that. These are sort of just best practices. And then finally, tune your targets according to the guidelines that we've laid out. There's much more information in our documentation that you can look at and use to your advantage. Q&A. Thanks for listening. Questions?
Does the MVCC impact asset or transactions in any way?
It shouldn't. No.
It's just for reads.
Just for reads.
It's just a query only. Yeah.
Sorry, should I repeat the question? Yeah, the question was, does MVCC affect ACID or any other properties? And it doesn't.
Can we enable profiling on some running session already?
Can we enable profiling on a server that's running already, like in production, for example?
Yeah, it is taking longer time and we want to analyze what is happening. Because we haven't started profiling to start with, but now it is running into some issues.
Well, you can certainly, any of the tools, most of the tools we've mentioned, like perf on Linux and any of these Windows tools, you can start in situ when it's running.
I'm talking about MarkLogic profiling.
Oh, you mean the actual, like something like doing, using the profiling API?
Yeah, where it's spending more time.
That's a good question.
So if you enabled debugging and tracing, right? Yeah.
Can you just turn it on though?
Enable profiling, then yes, you can do it.
Yeah. So you can turn it on just in the middle.
Okay.
From that point on, you'll get that trace information and the
But that session
debugging.
is already running, so I have to enable. I want to enable the profiling out from outside the session because that session is already running. We can't change any code in the
You can't change the configuration of that particular node.
No code in the production. Now that is taking more time suddenly, and we want to see why it is taking longer time.
I mean, for that, I would still use perf
Okay.
and to analyze, yeah, at least what are the areas of the system that are, the oldest. In terms of xQuery, it would be a little more difficult to do that.
Yeah, because
But
we had certain situations where everything was running fine and suddenly it took longer time, and this batch process.
Yeah, you can. I mean, you should. Perf will give you more information about where it's spending its time.
yeah.
So, I mean, if it's an application issue, ultimately you'll have to solve it at the application layer. But perf can lead you there.
Yeah, and the other thing is, again, try to get a snapshot of the health of the system, before you say, okay, this is the query is the problem. So, look at what is the bottleneck? Is it I/O? Is CPU? Because depending on what it is, then you have to use a different, tool to drill down. So, again, you use the use methodology. Look at all your resources and find out what is the utilization, the saturation errors, and then drill down as needed.
Sorry, him.
So you mentioned about Nagios. What are the other tools that you integrate with?
So Nagios, we have a plugin. I know there is a New Relic, not official plugin, open source. Somebody developed that. PCP, I mentioned that. Yes, REST is obviously the main thing. So you can collect, you can get any information through our REST monitoring API, and then you can push it to your tool,
Including the performance metering data.
Yeah.
Can you speak a little bit about the ops director in 9? Is that going to have more of the performance?
So the first incarnation of ops director is not going to include performance data specifically in the dashboard, but hopefully future iterations of that will improve upon that, and definitely getting your feedback as customers will help us a lot to improve that aspect of it. There will be metering data, I shouldn't speak directly on this because I can't remember now. Metering data is going to be available, right?
We'll be aggregating metering.
But not displayed in the same way as.
Current plan is to have an analyzed page, which is aggregated metering.
Right. Okay.
But that's not.
So we have the developer here. So you.
Very carefully speaks of plans.
Yes. Yes.
Are there any plans to implement any log forwarding within the application level of MarkLogic so you could better centralize your logging for
As it turns
clusters?
out. Ops director will also be receiving logs from management.
Sorry.
So you gotta see what people want.
There was a question about aggregating and forwarding log messages, and the answer is essentially yes.
The monitoring that you guys, that MarkLogic provides, is it common for customers to enable that in production environment?
Yes.
Do they do that?
Yes. Yes.
We hope that everybody will.
Are there certain kind of like levels, or is it turn on and you're getting?
Well, it's configurable to the extent that you can say how frequently the samples are collected, and certain other
Retention
configurations of
period,
that
yeah.
retention period, how long you keep hourly data, minutely data, historical data, and you can pull it out and analyze it in third-party tools, which is very useful. I'm sorry, did you?
Splunk. Yes.
Yep, Splunk is
We're
another.
using Splunk. Yes.
Another good one. Anyone else?
Do you know when the slides will be available online?
They said, Wendy, when were the Wendy, when are the slides available online?
June 1st.
June 1st.
MarkLogicWorld.com, all of the videotaping of the presentations as well as the slides will be available.
Anyone? Somebody from our own team want to ask us a question?
No.
Okay, well,
Thank you.
thank you.